Today I'm going to talk about the eel migration to the Sargasso, remarkable high swimming efficiency and low energy cost. In this paper, they choose the European eel angula for the example, and the smallest European eels are found in the Sargasso Sea, and the larger European eels are found near the Europe coast. And there are no eggs or adult eels had been found in Sargasso Sea, and these are the only evidence that the Sargasso Sea was their spawning ground. European eels migrate 5 to 6,000 kilometers from European coast to their spawning ground, Sargasso Sea, and to get there in 6 months. A mean swimming speed is 0.4 meters per second. For their migration, European eels swim 6,000 kilometers by consuming 40% of their body fat, and suggesting that they have enough energy for their trip. And an 80 centimeters female eel can swim at a steady speed for 180 days for their trip. But there are no direct proof that eels can keep swimming for 180 days for a low energetic cost. And to prove the Smith's theory, there are 3 hypotheses to match. And the first one is fasting eels must possess sufficient energy reverse from a 6,000 kilometers migration. And some researchers doubted that the fasting eels can finish the trip, and also thought that the European eels are the offspring of the American eels. But because of the DNA and enzyme analysis clearly distinguish the 2 Atlantic eel species, so it is being rejected. And for the second, mature European eels and fertilized eggs must be found in Sargasso Sea, but because of until now, only 2 reports of silver eels caught incidentally in open Atlantic, so it was being rejected too. And the third one, eel larvae must be shown to migrate towards European coast because they spawn in Sargasso Sea, so they need to go back to European coast. But because of large difference of age and genetic of European eels have not yet been resolved, so it was being rejected too. So the main goal of this paper is to determine the energy cost of swimming over a complete 5,500 kilometer swim in the laboratory. And how to set up the experiment. They use the black scar type flow tanks, and the tank is 10 meters long and can hold 127 liters of water. And there are 2 kinds of experiments. First, they choose 30 European eels for 173 days to simulate 5,500 kilometers migration. And the second one is a short 1-week test. They compared European eels and rainbow trout at the similar body size to see who is the efficiency species. And in these 2 experiments, all eels are in the non-migratory stage. And for the oxygen consumption, in the first long-term test, the eels swim in constant 0.5 body length per second. And the second one, short-term test, the rainbow trout swim slightly faster in 0.7 body length per second. And all the species in the experiment all swim in optimal swimming speed. And for the energy consumption analysis, there are two kinds of analysis. First is oxygen uptake. This is the volume of oxygen consumed. And the second one is bomb calorimetry. And this is total energy loss from their body tissues. And here is the formula. And for this graph is talking about oxygen consumption of the eels. And for the diamonds, it means the swimming eels. And for circles are the resting eels. And you can see that swimming eels consume 2.1 times more oxygen than the resting eels. And for their body constitution, the ratios of fat, protein, and carbohydrates stay the same proportion. And even after they lost a lot of weight from the trip. And also their body composition didn't change in same proportion. For their cost of transportation, the total energy can calculate by oxygen consumption rate multiplied by swimming hours. And the COT was calculated by a conversion factor and the total energy. And for the two independent analyses for COT, there are two main characters. First is the oxygen consumption of swim eels, and the bomb calorimetry of swimming eels. And for the important two numbers is the total energy consumption and the COT. In the oxygen consumption of the swimming eels, their total energy consumption is about 2,316, and their COT is 0.42. And in bomb calorimetry swimming eels, their total energy consumption is about 3,450. Their COT is 0.62. These two numbers are slightly different, but is in a same order of scale. And in experiment 2, you can see the oxygen consumption. The trout consume 3 times more oxygen than the eels. And in 7 days distance, you can see the eels swim more farther. In COT, you can see the trout use about 4 times more energy than the European eel. And for their muscle performance and efficiency, efficiency remains high only over a narrow range of tail beat frequency, and their muscles deliver peak power at lower contraction frequency than those of trout. So it shows that both eels and trout were swimming at close to their optimal swimming speed in the experiment. And for their metabolic cost and efficiency compared. In metabolic efficiency, the European eels have much higher metabolic efficiency than the rainbow trout. And for COT values from the oxygen analysis and the bomb calorimetry, the rainbow trout is much higher than the European eel. And also, eels swim 4 to 6 times more efficiently than many other fish species. So there are some conclusions. Fasting European eels can swim to Sargasso Sea with high swimming efficiency and low energy cost. And the only evidence for this high efficiency comes from their metabolic energy cost, and the source of the yell's remarkably high efficiency remains unknown. And thank you for your listening.
Hello, Mandy. I think it's a great presentation, but it's actually analysis instead of analysis. And my question is, did they mention how to measure the oxygen consumption in this paper? Because I'm kind of curious about it.
I think they just get the data from the eels and rainbow trout when they swim in a tank.
Oh, okay, understandable.
Can you tell me when it is swimming far away, then it will eat or just only swim?
In this paper, the eels swim to spawn in the fasting. They usually know it's when they spawn, when they swim to spawn.
Okay, thank you.
I want to ask about the experiment. Why do you choose the trout?
I don't know why the author chose the trout, but it just chose the similar body size to the eels, and I don't know why the author chose the rainbow trout.
Oh,
sorry.
okay.
Okay, so I think you gave a very smooth talk and quite clear, but there's still some place where you can improve. Here you, at the beginning, you talk about swimming from the Sargasso Sea to, you talk about the yield difference between the Sargasso Sea and Europe, but we don't know where Sargasso Sea is. So my suggestion is maybe you can switch, or at least switch the image here. You need to tell us where is Sargasso Sea when you talk about Sargasso Sea, not later. And then, then you start to talk about three interesting theory. Although I was wondering, because you have three hypotheses, I really wonder which one is Smith's theory. And I don't know what this theory is about. Maybe you can briefly talk about what this theory is about. And then why there are three hypotheses. And these three hypotheses, they are nicely presented because you use the cartoon to explain the three different hypotheses. But at the end, they were all rejected. So I was sort of, so what is the relationship between these hypotheses and your purpose? This link is missing. And furthermore, in your conclusion, I was hoping that maybe you will revisit, come back to these three hypotheses and maybe tell us the results support which hypothesis, but you didn't tell us that. So there was a little bit a lack of coherence, 就是那个起承转合不够. So you need to improve your coherence by telling us the relationship of your experiment to these hypotheses. And then when I was listening to this, you made this nice comparison, which is okay, nice. And this was also done by yourself, right? However, I was really wondering how do they make the eel swim for so many days in a tank like this, for which is only 2 meters long. Maybe you can tell us how do they make the eel swim all the time. Tell us more about the experiment. And this is okay. However, because here you have experiments 1 and 2, and later you also have these different parameters, I suggest that, and later we already sort of get lost which experiment is what. So maybe you can have a small icon here for your experiment 1, which is maybe swimming versus resting, right? Is that right? Okay. And experiment 2 is, sorry, I don't remember which one is experiment 1 and 2. So maybe you can use a simple icon. And later when you talk about your result, you can tell us this is from this experiment by show this icon. Like a eel versus trout, or swimming versus resting. You can design your small icon to remind us that. And here you is nice that you didn't spend too much time on this equation. That's the right thing to do. And then, as I said, when you started to present this, I start to get lost. Which experiment is are you talking about? So it would be great to tell us the experiment. And here, because it's nice you remade the table, but whenever you need to present the table, you need to tell us what is the key number, like here. You need to tell us the key number. And if the thing is there's no difference, then you tell us clearly, no difference. Okay, because there are so many numbers. My eyes were looking around. I don't know which one to look at. And then at 16, you have a term where you say the same order of scale. That's not a phrase we usually say. We say the same order of magnitude. And then, as I suggested, because of so many experiments, icons of experiment. And of course, if possible, it would be great if you can use self-made image by Excel. That would be the best. Because tables is usually painstaking to read with so many information. Use image if possible. And then there's a place where you try to explain why the eel has such a high swimming efficiency. And we start to see this. And my feeling is, please ask your good friend ChatGPT how to convert this to plain language. 白话文啊，用白话文解释。This is a little bit too difficult for me. Or maybe you can ask Professor Wang Jingyong. Maybe he can explain that easier. It's about biophysics. And then, and here you say about this and that. Maybe this one larger, this one smaller. Maybe you can print the corresponding value here. Because I thought this is from your experimental results. Maybe you can print the value. Cite the value here. Here you have value. Okay, so at the end, I hope you can come back to hypothesis and tell us which one you support. Okay, good. Hope to see improvement next time. Thank you.